Okay, today we're looking at a review of the 7 basic units used for measuring in the SI system. The ones that are most important to us are mass, length, and time, although we also have temperature, the amount of substance, electric current, and luminosity. The units for mass, length, and time are the kilogram, the meter, and the second. Their abbreviations are kg, m, and s. The units are combined to make what are called derived units to measure, for example, distance. In a linear sense, we use meters. To measure area, we would use meters squared. And to measure volume, we would use 3 dimensions, and it comes up to units of meters cubed. So for example, if I wanted to measure the volume of a cube that had a height of 3 meters, we know that a cube has all the dimensions the same size, so it would be length times width times height, or 3 meters times 3 meters times 3 meters, which gives us 27 meters cubed. There are 3 ways of writing the same thing, which students should be aware of and which often causes confusion. You could say 3 meters all cubed, which means that cubed is being distributed to everything inside the bracket. So 3 cubed and meters cubed will give you 3 cubic meters cubed, which equals 27 meters cubed. It's also probably advisable to remember all the cubes up to 10. So I've listed them here. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, 10 cubed is 1,000. Why would we do that? Because it allows us to recognize when we see those numbers that if we take the cube root of a certain number, we can find the length of a cubic object. So for example, if you know that a cube has a volume of 8 meters cubed, you would know right away that if it's a cube, and because all of its dimensions are the same, that its edge length would be 2 meters. Another trick that might be useful to know at your grade level is how to cancel numbers that appear in conversion factors or fractions. And I've shown here how 1/2 times 2/3 times 3/4 times 4/5 times 5/6 and so on is multiplied, and it equals 1/10. Now if you use the calculator, you would get the correct answer, but it would take you a couple minutes to enter all those fractions. But you can see very clearly and quickly that 2 and 2 cancel, 3 and 3 cancel, and so on, all the way through the line, so that you can get 1/10. When units are converted, it is necessary to use a conversion factor. And conversion factors tell you how many of one unit is equal to another unit. So for example, when you think of a cow, you think of an animal with 4 legs, and if you thought of 3 cows sitting in a field, or standing in a field, you would realize immediately that there are 12 legs. 3 cows, 4 legs each cow, 12 legs. So there's a conversion factor inherent to almost everything we do that involves units. For the SI system, it's very easy because everything is based on the number 10. So 1 meter is equal to 100 centimeters. That gives rise to 2 conversion factors. We can either write 1 meter per 100 centimeters or 100 centimeters per 1 meter. Likewise, we can say that 1 meter is 1,000 millimeters, which gives rise to these 2 conversion factors. It's important to know that both of these possibilities are the same. They represent the same quantity or conversion factor, but you would use different ones under different situations. So for example, if I said our football field is 100 meters long, how many centimeters is that? I would use 100 centimeters per 1 meter. Why? Because I'm trying to eliminate meters in the numerator. So I have to put meters in the denominator to be able to cross out meters. 100 times 100 will give me 10,000 centimeters. You see that centimeters didn't cancel out, so that gets transposed over here, and we write the final answer. And we use a lot of this conversion in later on in more advanced chemistry courses. So it's very good to learn and become very acquainted with these conversion factors. Another example, the football field is 100 meters long. How many millimeters is that? Well, the conversion factor from meters to millimeters is 1,000 to 1. Which one of the 2 do I use? The one where I put millimeters on the bottom or the one where I put millimeters on the top? Well, I'm trying to eliminate meters in the numerator, so I'm going to put meters in the denominator. That means millimeters has to be on top. 1,000 times 100 gives you 100,000. And millimeters doesn't cancel, so I transpose it over here. Incidentally, I could rewrite this number, given that the decimal place is here on this number, I could rewrite the number by moving the decimal place 5 times. I skip 3, skip 2, I put the decimal place here right after the 1, and I get 1.0 times 10 to the 5. Moving on to area and volume conversion. If the football field is 35 by 100 meters in length, 35 meters wide, 100 meters in length, what is its area in meters squared, centimeters squared, and millimeters squared? The first step is to find its area in meters squared. So 35 meters by 100 meters gives you 3,500 meters squared. Notice how meters times meters gives you meters squared. You can also rewrite the answer by moving the decimal place over 1, 2, 3 times. You could say 3.5 times 10 to the 3 meters squared. Now, if I wanted to convert each measurement individually into centimeters, I could do it. And that's what I'm doing here. I'm saying 35 meters times 100 centimeters per meter. Meters cancel. That's 3,500 for the width. 100 meters by 100 centimeters, that would be the length of the field. If I write those two conversion factors after canceling everything that can be canceled, I get 3,500 times 10,000, and you get 35 million centimeters squared. Centimeters by centimeters gives you centimeters squared, which I can also rewrite by skipping 3, 6, 7 decimal jumps, 3.5 times 10 to the 7 centimeters squared as well. You could write it as a scientific notation. But there's a faster way of showing this calculation, and that is to recognize that when you convert area, you have to have the conversion factor raised to the power of 2. You always start with a linear conversion, but because measurements are always using the same unit, but in different directions, depending on how many directions you have to use that unit, you simply raise it to that power. So if it's length, the power will be 1. If it's length times width, the power will be 2. If it's length times width times height, it has 3 dimensions, you would raise it to the power of 3. So the area of our football field can also be calculated in one simple step, where we know the conversion factor for centimeters is 100 to 1. Again, we put meters on the bottom, raise it to the power of 2. 100 times 100 gives you 10,000. 10,000 times 3,500 gives you 35 million. And meters will cancel. See, this meters becomes meters squared. That's why we're allowed to cancel it. And I'm just showing here how you can do the same calculation into millimeters. There are 1,000 millimeters per 1 linear meter. If we want to convert to area, we have to raise it to the power of 2. And be aware of the fact that when you raise something inside of a bracket to the power of 2, you're raising everything inside the bracket to the power of 2. That's why I wrote all those arrows, although it looked kind of messy, so I'm going to get rid of them now. So 1,000 times 1,000 gives you a million. 3,500 times a million gives you 3.5 billion, 3,500 million. Notice how the meters squared cancel. Millimeters doesn't cancel, and so it's transposed to the final answer. And again, if I took the decimal place and I moved it over 9 times, I would get 3.5 times 10 to the 9 millimeters squared. Same answer written in scientific notation. Any questions? Yeah? Do you have a question? Oh, no, okay. Very good.